Hello all, welcome to Akrati Educations. Today we will learn the concepts to find the number of integral solutions of an equation. So today we will going to discuss about number of integral solutions of an equation. So suppose if we start from a basic equation, we are given with an equation say x1 plus x2 is equals to 4, and both x1 and x2 are the natural numbers, and our task is to find the number of integral solutions of this equation. As we know that x1 and x2 both are natural numbers, so it means the integral solutions will be positive. Now if you observe, then you will find that the possible integral solutions are 1, 3, 2, 2 and 3, 1. So it means the total number of positive integral solutions of this equation is 3. Now further, if we change the constraint on x1 and x2, and let's say they belong to the category of whole numbers, we know that whole number starts from 0, so it means the integral solutions will be of non-negative category. So there will be two additional solutions from the positive part. It will be 0, 4 and it will be 4, 0. So the total number of integral solutions, say non-negative integral solutions, will be 5. But say we are given with an equation x1 plus x2 plus x3 plus x4 is equals to 400. So will it be feasible to find all the solutions in the same manner which we have done in the previous example? No, because there will be lot of solutions and it is not feasible to count after finding the solutions. So we need some small tricks to find the number of solutions with respect to any given constraints on the variables. So again, let's go back to the equation 1. x1 plus x2 is equals to 4, and we are given that x1 and x2 belongs to the category of natural numbers. It means that we need to find all the possible ways so that 4 things can be put into 2 boxes such that no box is empty. No box is empty, it means they are the positive solutions, and that is equivalent to find the coefficient of x raised to the power 4 in the expansion of x plus x square plus x cube and so on multiply x plus x square plus x cube and so on. Now if you look at each individual expansion, then it has power x raised to the power 1, x raised to the power 2, x raised to the power 3 and so on, it is going on. We also know that natural number starts from 1. So it means whatever is the domain or whatever value a variable can take, these will act as the power in the expansion. So 1, 2, 3, 4, 5, 6 and so on. Similarly 1, 2, 3, 4, 5, 6 and so on. So now we need to find the coefficient of x raised to the power 4 in this coefficient. So x raised to the power 4 can be found by either multiply x with x cube, x square with x square and x cube with x. So you will notice that in each part the coefficient is 1 and the sum is 1 plus 1 plus 1 is equals to 3. That we obtained earlier as well. Similarly, if x1 and x2 belongs to the category of the whole numbers, then we need to find the coefficient of x raised to the power 4 in the expansion of this. So here we have changed the expansion a little. Here it is starting from x raised to the power 0, because I have told you that whatever is the value these variables are taking, this all will be in the powers of the expansion. So whole number starts from 0. So that's why x raised to the power 0, x raised to the power 1, x raised to the power 2, x raised to the power 3, and so on. Similarly, it goes for variable x2, and that's why we have written expansion like this. So now we can find the coefficient of x raised to the power 4 as 1 into x raised to the power 4, x into x cube, x square into x square, x cube into x, and then x raised to the power 4 into 1, and the final answer is 5. Okay, so it is similar to the previous case. So it means we have developed our theory. So in general, if you are given with an equation having n variables, x1 plus x2 plus x3 up to xn is equals to k, and the constraint is that each xi is between ai and bi, where both a and b are integers, and we need to find the integral solutions. Then, as I told you, that whatever the values are taken by the variable, these all will be in the powers. So xi can take value ai plus 1 up to bi. Similarly, x2 will take a2 plus 1 up to b2. So the product of this, and then we will find the x raised to the power k to find the desired number of integral solutions that obeys the given constraint. In this special case, if we need to find the positive integral solutions, it means all x belongs to the natural numbers. So it means we need to find the product of x plus x square up to so on for n variables. So it means this, and it can be simplified as x raised to the power n times 1 minus x raised to the power minus 1 using the binomial expansion. If you expand this, then you will find the coefficient of x raised to the power k. That will be, we have to multiply x raised to the power n also. So this will be the answer. So it means if you need to find the number of positive integral solutions, then the answer will be k minus 1 c k minus n. You can also observe that if k is less than n, then there will be no positive integral solution. For example, x1 plus x2 plus x3 is equals to 2. So there cannot be any positive integral solution. Now in the special case 2, if we need to find the non-negative integral solution, it means all xi can take value 0 as well. So it means we need to expand 1 plus x square for n variables, and in the using the binomial expansion it will be 1 minus x raised to the power minus n, and the coefficient of x raised to the power k will be n plus k minus 1 ck. Now we will solve some basic equations. Say we need to find the positive and non-negative integral solutions of x1 plus x2 plus x3 is equals to 5. So the number of positive integral solution, as we have derived the formula k minus 1 c k minus 1, so it will be 4c2, it is equal to 6. Similarly, number of non-negative integral solutions will be n plus k minus 1 ck, that is 7c5. Now let's generalize our theory. Say we are given with the equation 2x1 plus 3x2 plus x3 is equals to 6, and we need to find the total number of non-negative integral solutions. So we need to find the coefficient of x raised to the power 6 because right hand side has the term 6. We need to find the expansion. So since we have to take non-negative integral solutions, it means all x1 and x2 and x3 belongs to the whole number. But if you observe, then 2x1 can take value 0, 2, 4, 6. So it means for 2x1 we will have to write expansion like this. For 3x2 it will take 0, 3, 6. So So as we have already discussed that whatever values are taken by the variable, this will be in the power of the x. And similarly x3, then 1 plus x square plus x cube plus so on. Now if we multiply the first two terms, then it will come out like this, and the third term is, we have kept it as it is. Now we need to find the coefficient of x raised to the power 6. It will come out as 1 into x raised to the power 6, x square times x raised to the power 4, x cube times x cube, x raised to the power 4 times x square, x raised to the power 5 times x, and then 2x raised to the power 6 times 1. So overall the answer will be 7. Similarly, if we need to find only the positive integral solutions, so it means there will be a slight modification in the expansion. It will, for the first x1, it will be x square plus x raised to the power 4 and so on. For second variable, it will be x cube plus x6 and so on, and for third variable it will x plus x square plus x cube and so on. If we multiply first two, then it will come out as this one, and the third kept it same. So the coefficient of x raised to the power 6 is obtained by x raised to the power 5 times x, so it is same as 1, and the only positive integral solution is 1 comma 1 comma 1. Let's add further constraint that x1 belongs to minus 1 to 2 and x2 belongs to minus 2 to 4, and we are given with the equation x1 plus x2 is equals to 4. So x1 can take value minus 1, 0, 1 and 2, and similarly x2 can take minus 2, minus 1, 1, 1, 2, 3 and 4. So coefficient of x raised to the power 4 is obtained by 1 into x raised to the power 4, x times x cube and x square times x square. So the answer is 3. Similarly, we are given the equation x1 square plus x2 is equals to 4 with the same constraint as in the previous example. x1 is from minus 1 to 2 and x2 is from minus 2 to 4. So if x1 is in between minus 1 to 2, then x1 square will take value 0, 1 and 4. If you observe that for x1 square is equals to 1, there are the two associated values. x1 can take either minus 1 or plus 1. But for x1 square is equals to 4, there is only one associated value which is obeying the given constraint, as x1 is equals to 2. So it means for 0 it is frequency 1 and for 1 it has frequency 2. So the coefficient which has the power 1, we have multiplied it by 2. But for 0 and for 4 we have not multiplied, we have only multiplied it by 1. For x2 it will remain same, x raised to the power minus 2, x raised to the power minus 1 and so on. Now if you find the coefficient of x raised to the power 4, then it will be 1 into x raised to the power 4 plus 2x into x cube and x raised to the power 4 times 1. So answer will be 4. Further, we are given the equation as 2x1 square minus x2 is equals to 4 with the same constraint. Then for x1 as minus 1 to 2, x1 square can take value 0, 1 and 4. So 2x1 square can take value 0, 2 and 8. But for x1 square is equals to 1, there are the two associated values, plus 1 and minus 1, as we have already seen. For x1 square is equals to 4, there is only one associated value, as we have seen in the previous example also. Now x2 is from minus 2 to 4, so minus x2 will be from minus 4 to 2. So it means we have to change the expansion for x2 term. So it will be from my x raised to the power minus 4, x raised to the power minus 3, x raised to the power minus 2 and so on up to x square. So the coefficient of x raised to the power 4 will come from 2x square times x square and x raised to the power 8 times x raised to the power minus 4. So answer is 3. Further, the given equation is x1 square plus x1 plus x2 is equals to 4. So there are the two terms which have the variable x1. So what we will do is that for the given constraint or the value of the variable 1, x1 square can take 0, 1 and 4. So x1 square plus x1 can take value 0, 2 and 6. Now x1 square plus x1 can take value 0 for x1 is equals to 0 and for x1 is equals to minus 1. But for 2 and 6 there are only one associated values respectively. So it means for coefficient 0 there will be a multiplication index 2, but for 2 and 6 there will be only multiplication index 1. So the expansion will be 2 plus x square plus x raised to the power 6, and for x2 it will remain same. So if you find the coefficient of x raised to the power 4, you will get your answer as 4. So in summary, if we say that we need to find the solution of a general equation, say we have limited our discussion up to the polynomial equation. So all f are the polynomial functions with possibly all the rational coefficients. Okay, so we can convert all the rationals into the integral coefficients, and all these are the integral valued polynomial functions. So it is taking, say, f of xi taking values a1i, a2i, ari, and each aj has the frequency mji. Then we need to find the coefficient of x raised to the power k in this expansion. So this will be the desired result. If you find this video interesting, please like, share and subscribe our channel.